Hello, welcome to part two of the similarity and right trigonometry test review. Our next problem is number 12. It says a flagpole casts a shadow that is 19 feet long. The angle of elevation from the shadow to the top of the flagpole is 35 degrees, and we're going to find the height of the flagpole. Now, I have a diagram over here, and this is the flagpole, and here's the flag attached to it. It says the flagpole casts a shadow that's 19 feet long, and we know that a shadow is always on the ground. So the 19 feet will go on the bottom of the triangle. It says the angle of elevation from the shadow to the top of the flagpole is 35 degrees. Whenever you see angle of elevation, remember that elevation rises, so the 35 degrees has to be on the ground. And it asks us to find the height of the flagpole, and height is going to be the vertical distance, so I'm going to put an H right here. Now, we're going to find the height, H, by using a trig ratio. In order to do that, we always label the triangle in reference to this angle here. So H is going to be the opposite side, and 19 feet is going to be the adjacent side. Now, this is the hypotenuse. However, we don't know it, and we're not being asked to find it, so for this particular problem, we don't care about it. Now, recall our acronym, KOTOA, and from this acronym, we see that we have to use the trig ratio tangent because we're dealing with the opposite and adjacent side. So I'm going to write the tangent of 35 degrees equals opposite over adjacent, and we're going to fill in tangent of 35 degrees equals the opposite side is H, the adjacent side is 19, and we're going to next put the tangent of 35 degrees over 1 in order to turn this into a proportion. Next up, we'll cross multiply. Now, when we cross multiply this way, 1 times H is simply H. When we cross multiply this way, remember that whatever is on the bottom always goes first, so it's going to be 19 times the tangent of 35 degrees. And let's bring up our calculator. And we're going to type in 19 and then simply tangent 35. And we get 13.3 feet if you round to the nearest tenth. All right, next up, number 13, it says a 10-foot ladder is leaning against the house so that it reaches a window that is 8 feet off the ground. What is the angle that the ladder forms with the ground? So here's a diagram. This is our house over here. This is the ladder, and this height here is 8 feet. That represents the window. And it asks us to find the angle that the ladder forms with the ground. That would be this angle that is here. So in order to do this, we're going to use a trig ratio once again. And of course, once again, we're going to have our KOTOA, and let's label in reference to this angle that we're looking for. 10 feet is going to be the hypotenuse. So the ladder is going to be the hypotenuse. This height here, 8 feet, is going to be the opposite side. And we can see from SOHCAHTOA that we have to use the trig ratio of sine. Now, I don't know what the angle is, so I'm going to just put this in here and call that x, because we have no idea what the angle is. So we're going to say the sine of angle x equals opposite over hypotenuse. Next, the sine of angle x equals the opposite side is 8. The hypotenuse is 10 feet. Now, remember that we're looking for an angle. Whenever you are looking for an angle, we are not going to do any cross multiplying. Instead, we're going to use an inverse trig ratio. So I'm going to write x equals the inverse sine, so that's the sine with the -1, of 8 over 10. And let's plug this into the calculator. In order to get inverse sine, we hit second and then sine, and then 8 divided by 10, and we get back 53.1 degrees. All right, next up, number 14, it says in the figure below, the two triangles are similar. Triangle ABC is similar to triangle XZY, and it asks us what is the tangent of angle X. If these two triangles are similar, then their angles are going to be the same. Therefore, angle A is going to be congruent to angle X. Angle C is going to be congruent to angle Y, and angle B is going to be congruent to angle Z. Now, if the two triangles are similar, then their trig ratios are also going to be similar. Therefore, the tangent of angle A is going to be the same as the tangent of angle X. And we can say the same thing for the tangent of angle C, tangent of angle Y, and so on. Now, in order to find the tangent of X, what we're going to do is find the tangent of A. And to find the tangent of A, once again, so Katoa, and this reminds us tangent is opposite over adjacent. So if we're talking about angle A, 32 is opposite, and 28 is adjacent. 45 is the hypotenuse, but we're not looking for that, and we don't need it for this particular problem. So we're going to write tangent of A equals opposite over adjacent. So tangent of A equals the opposite side is 32, and the adjacent side is 28. And we can plug this into the calculator. So 32 divided by 28. And we get this decimal here, so 1.14. So tangent of A equals 1.14. Now, you can write it like this, or you could have reduced 32 over 28, could have simplified it. And the biggest number that goes into 32 and 28 evenly is 4. 32 divided by 4 is 8, and 28 divided by 4 is 7. So if you put 1.14 or 8 over 7, either of those answers would be acceptable. All right, next up, 15, it says find sine A and cosine A in fraction and decimal form. So it tells us that we are talking about angle A. And of course, we have to label the triangle. So let's go ahead and label the hypotenuse first. That'll be 17. We know that's the hypotenuse because it's the longest side. It's across from the right triangle. 15 is opposite, and 8 is adjacent. Once again, we have so Katoa. Let's do sine first. So sine of angle A is going to be opposite over hypotenuse. Opposite is 15. Hypotenuse is 17. Now, this can't be reduced, so this is the fraction form. Now, in order to find the decimal form, plug it into the calculator. So 15 divided by 17, and 0.88 we can write. 0.88. So there's my fraction form. There's my decimal form. Next up, cosine. Cosine of angle A, adjacent, let's rewrite that, adjacent over hypotenuse. The adjacent side is 8. The hypotenuse is 17. This can't be reduced any further, so let's find the decimal form. 8 divided by 17, and we can write 0.47. So the fraction form of the cosine is 8 over 17. The decimal form is 0.47. Okay, next up. 16 and 17, we use this figure here. It says find the measure of side AC. So I know I'm looking for that. And I'll put an X there. We don't know what it is. And it also says find the measure of angle A. I'll actually do 17 first. 17 is pretty simple. We know that angle A and angle B are the acute angles in a right triangle. The acute angles in a right triangle have to add up to 90 degrees. So in order to find the measure of angle A, we're just going to subtract 24 from 90. So 90 minus 24. And 90 minus 24 is 66 degrees. Okay, next up, it says find the measure of side AC. And we're going to go ahead and just label in reference to the 24-degree angle. If you'd like to label in reference to angle A, that would be fine. So X is opposite the 24-degree angle. 14 is the hypotenuse. And once again, from SOHCAHTOA, those two sides are part of the sine ratio. So the sine of 24 degrees equals opposite over hypotenuse, and the sine of 24 degrees, I'm going to plug in X for opposite and 14 for hypotenuse. We're going to put the sine of 24 degrees over 1, and then we're going to cross multiply. 1 times X is X. When we cross multiply this way, remember that this number that's in the denominator, whatever's in the denominator, is going to come before the trig ratio. So 14 times the sine of 24 degrees, and let's plug that into our calculator. So 14 sine 24. And if you round this to the nearest tenth, there's a 9 here, so you would round this up to 5.7. And that would be 5.7 meters. All right, next up, number 18. It says in the figure at the right, triangle JKL, what are the measures of the acute angles? So we have two sides, and we have to find the measures of angle J and also angle K. Now, we don't have either one to begin with. We do know that they both add up to 90, but we have to find one of them first. So let's find angle J first. And if we're going to find angle J first, as always, we have to label in reference to the angle. So 4 is adjacent to angle J. 6 is opposite. And this is the hypotenuse, but we don't know it, and we're not looking for it, so we're not going to worry about it. Once again, SOHCAHTOA tells us that we have to use tangent because we're dealing with these two sides, opposite and adjacent. So I'm going to write the tangent of the angle is J. I don't know what it is. Equals opposite over adjacent. So the tangent of J equals the opposite, 6, over the adjacent, which is 4. Now, once again, we do not cross multiply because we're looking for an angle. Whenever you're looking for an angle, you have to use an inverse trig ratio. So I'm going to write angle J equals the inverse tangent of 6 over 4. And let's plug this into our calculator. To get inverse tangent, we do second tangent, 6 divided by 4. And we're going to round that to 56.3 degrees. Now, we have to find angle K. We could do another inverse trig ratio if we want, but we do know that angle J and angle K are the acute angles of a right triangle, so they have to add up to 90 degrees. So we know that K is going to be 90 minus 56.3, and we can plug that into the calculator certainly. So 90 minus 56.3, and we'll get 33.7 degrees. Okay, next. Number 19, it says find the perimeter of a square that has a diagonal of 24 inches. Now, I've drawn a figure here. Here's the diagonal. We know that a square has 4 equal sides and also has 4 right angles. Now, I've drawn 2 of the right angles here because these 2 right angles get cut in half by the diagonal. Being that they get cut in half, we know that this angle has to be 45 degrees, and this angle also has to be 45 degrees. Now, I'm looking for this side, or I can put this side or this side because they're the same. I'm going to call that S. So to find the perimeter, the formula for the perimeter of a square looks like this. P equals 4S. Basically 4 times the length of one side because all 4 sides are equal. In order to find S, what we have to do is once again use a trig ratio. So SOHCAHTOA. And in order to know which one to use, we have to label. Let's label in reference to this angle down here. 24 is the hypotenuse. S is the adjacent side. And we're going to use cosine in order to figure this out. So we're going to write the cosine of 45 degrees equals adjacent over hypotenuse. So the cosine of 45 degrees equals the adjacent side is S, I don't know what that is, over 24, which is the hypotenuse. We put the cosine of 45 degrees over 1, because this time we're not looking for an angle. We're going to cross multiply. 1 times S is S. And the cosine of 45 degrees times 24, we're going to write as 24 times the cosine of 45 degrees. So let's type that in. 24 times the cosine of 45. And we're going to get 16.97. If you actually round this to the nearest tenth, this is a 7. This is a 9 here, so you would round up 1. So we would just round this up to 17. Now, I'm not done because remember it asks us to find the perimeter. Perimeter is equal to 4s, so we're just going to plug in. So P equals 4 times s. So that equals 4 times 17. And 4 times 17 is 68. And that would be 68 inches. All right. All right. Next up, we have number 20. Find the area of an equilateral triangle that has side lengths of 20 centimeters. And here's some hints that we're given. The area of a triangle, the formula is 1/2 base times height. And an equilateral triangle is also equiangular. We're going to draw a sketch. So here's our sketch. We have our triangle, and we know that it's equilateral. So we have 20 centimeters over here, and we're also going to have 20 centimeters over here. Now, base times height, we do have the base. The base is 20 centimeters, and I'm not going to put that in just yet. The height is perpendicular from the base. So I'm going to draw that in, and let's draw that in. All right, and it's going to look like so. Now, this is the height, which we do not know. This height cuts the triangle in half. Now, if the bottom here is 20 and it's cut in half, then each side is going to be 10 centimeters. We also said that the height is perpendicular to the base, so there's going to be a 90-degree angle here. In order to find the height, which is all we need to plug into the formula because we already have the base, we're going to do the Pythagorean theorem because I have a right triangle here on the left, and we have two sides of the right triangle, so we're going to do the Pythagorean theorem. So we're going to write a squared plus b squared equals c squared. Whenever you do the Pythagorean theorem, you have to be careful about where you put the value of c. C has to be the hypotenuse, and that is 20 in this case. So for a, we're going to type in 10 squared. For b, we're actually going to type in h, that's what we're looking for. C, we're going to type in 20 squared. Now 10 squared is 100, plus h squared equals 20 squared is 400. We need to get h by itself, so let's subtract 100 from each side. 100 minus 100, that becomes 0. We bring down h squared. 400 minus 100 is 300. And to solve for h, we want to take the square root of both sides of the equation. The square root of h squared is h. And let's see what the square root of 300 is. We do second x squared and type in 300. And we get 17.3. So h equals 17.3, and that would be 17.3 centimeters. Now we're going to take everything we have and plug it into the equation. So the formula for the area of a triangle is 1/2 base times height. 1/2. Now I'm going to do this for the whole triangle. The height of the whole triangle we already figured out is 17.3. The base of the whole triangle is 20 centimeters. So that's what I'm going to plug in for B. So 1/2 times 20 times 17.3. And if you type this into the calculator, you should get 173, and that would be centimeters squared.